Inheritance is a big part of object-oriented programming, as are interfaces. However, the two can often get confused. Knowing when to use inheritance and when to use an interface is important. In this lesson, we're going to talk through when to use inheritance and when to use an interface instead. Then we'll look at an example to illustrate these principles firsthand by first getting it wrong and then following best practices to use both interfaces and inheritance each in their best possible manner to get the best possible result. Now, if this is the first video you've seen of mine, my name is Tim Corey and it's my goal to make learning C# easier. I provide videos twice a week here on YouTube to help you grow as a developer. I also have a full set of training courses on IamTimCorey.com. I encourage you to check out all the resources that I have to offer. Now in this video, as with most of my videos, I'm going to create some source code. And if you'd like a copy of my source code, use the link in the description. Let's get started by going to Visual Studio. We're going to create a very simple project. Let's create a console application, .NET Core, actually .NET 5. Let's call this the OO demo, and we'll call this OO demo app. And OO would stand for object oriented. We're going to use .NET 5 and we'll hit create. We're going to use a console application here because the point here is not to write code that you'd put in production. The code is to see. It's just a means to demonstrate what we're talking about. So let's start off right up front talking about what is and isn't a good use of inheritance. Now, if you're not familiar, the idea of inheritance is you have a base class and then you have a class that inherits from that base class and pulls those properties and methods into that child class. So let's talk through when's a good idea and when's it not a good idea to use inheritance. And one key thing to note here, and this is often something that when you start using inheritance, you get wrong, and that is inheritance is not code sharing. That's not really what it is. If you were going to do code sharing, you could do it in a number of different ways that don't require inheritance. For instance, if you want to share code, just put that code in a separate library or a separate class and reference it in two different locations. We do that all the time. We create methods that we pull from and call in other areas. We create classes with methods and call them from other areas. So code sharing, that's not what it's about. It's not about code sharing. It's more than that and different than that. Now, also, in order to have good inheritance, you need to have a relationship. You may have heard it before, but what it is when you say, is this thing A? So is a cat an animal? Well, yes. So therefore, animal could be a base class and cat could be a child class of the animal base class. So that would work. But is a car a house? No. But you can put people in it and maybe even sleep in it. Yes, but there's not that is a relationship there. Therefore, car really can't be a child class of house, and we can't even have a base class of sleeping place. That doesn't really make sense there. So, and we need to also need to share common logic, not just properties, not just method names. They need to share common logic. Otherwise, what's the point? Why are you doing inheritance at all? All right, so that's another key thing. And then let us spell this out here. Sharing just properties or method signatures is not enough. Okay, so when we're talking about code sharing, if you just have, well, all of my things have this method signature. They all have different implementations, they all have a method signature. Therefore, we're going to share that and not repeat ourselves by having that same signature more than once, but we'll have to override it each time. That's not really stopping yourself from repeating yourself. It actually makes more code for no real value. Now, next up, inheritance. Wow, I spelled that wrong. Inheritance can put you in a corner. This is something that often doesn't show up until it's too late, and that's a really painful lesson. And that is when you start going down the inheritance road, you can really stretch the is a relationship. And we're going to do that today a little bit. But it's going to make sense at first. And that's the dangerous thing, is it starts to make sense at first. You're like, well, yeah, but these have a relationship because they're all part of this. Yes, but you're stretching that. And when you stretch that, what happens is you later get faced with a situation where you're like, now the relationship I need doesn't make sense across the board. So now I have some really weird things to work through, or I have a lot of refactoring to do. And that's not ideal once you have an application in production. And finally, let's just say this, that you need to ask the question, what is the point? Okay, now you may say, well, what does that question mean? Well, when you're doing inheritance, you need to ask the question, what's the point of doing inheritance? What's the value here besides the fact that we can? Are we just sharing property signatures and method signatures? Well, that's not really any kind of value. In fact, it's locking us into something that doesn't add anything, and it does make things more complex. Therefore, it's the opposite of helpful. It's actually harmful. So that question right there, what's the point? What's the value you're getting out of your inheritance that you wouldn't get out of doing it a different way? Like code sharing. Well, if it's just code sharing, then you just create an external class and put a method in there. Now it's shared. Is that all it was? If that's all it was, then you don't really have a point here. Now, I know this is all to, don't pardon the pun, a bit of an abstract talk. So let's get into the nitty gritty and actually write some code to see how inheritance can go wrong, how using interfaces can help, and how we can use both effectively. So let's create a class. We're going to create a class. We'll create all of our classes in this namespace at first, and then we'll move them off to their own files. So let's create a public class rental car. Now we're going to say that, I'll put it up here, we are a rental agency in Miami, Florida. Okay, so we're going to rent cars. Cool. So we're going to create a class called rental car, and the rental car will have a number of properties and methods. So let's put those in before we move it over. We're going to say prop, tab twice. We're going to say rental ID. This is just the ID of this particular vehicle in our inventory. We'll have another property that, let's just say string and current renter. Now, I am just roughing in these classes. These classes are all examples. So don't get too hung up on, well, I'd actually add this or change that to be a, like for this, I would have it be a person model or have a rental contract we put in there, something like that. But again, this is an example. So we'll have one more, let's say decimal. This is the price per day. And then we'll have some information about the car itself. So I'm just going to say number of passengers. And then we're going to have two methods in here. We're going to have a method that is a start engine. And we're going to say just console write line, turn key to ignition setting. And then we'll have one more console write line that says turn key to on. Okay, so you turn it all the way to ignition to start it, and then turn it back to the on position. That's how you start a car. Okay, again, very basic stuff here that, of course, we want a better method for. We're also going to have a public void stop engine. And in here, we're just going to have a turn key to off. That's it. So that's our class. So let's look at this real quick. We have some information about the rental. Okay, so rental ID, current renter, price per day, and then we have some information about the vehicle itself, number of passengers. We could go make, model, all the rest, but this is all we have for now, and then a start engine and a stop engine method. Well, and let's add one more. We need to add a enum. I'm going to right click and add a class. My enums I do a little bit different. I create a class for them called enums because I put all my enums in one spot. So I get rid of the actual class, but I have a file called enums then. And in here, we're going to say public enum, and we'll say car type. And in here, we'll say, my shift enter is not working. All right, no problem. I'll say hatchback. Then let's say sedan and compact. So that's our 3 car types. Yes, there's more than that. So then over here, we'll have our enum, car type, and we'll say style. Okay, so that's the style of vehicle you're getting. So let's save this. We'll actually move this over. So control dot and move type to rentalcar.cs. Okay, so there's our class. It actually moved over the comments here, which is interesting. So they're here as well. I'll go ahead and actually remove them from program. Otherwise, it's going to copy it over to every single class we create. We don't want to do that. So now they're just in rental car. So that's where those comments are from the beginning. Now, so we start renting vehicles. We're like, okay, cool. We're renting vehicles. We've got 5 cars in the lot. It's a small car rental agency, but we're growing. And then our boss comes to us and says, hey, guys, good news. We've got our first truck to rent. And you're like, uh-oh, because we have rental car. And so we've got things that only trucks have. Well, that's a problem. So we're like, okay, no problem. This is where inheritance comes to the rescue. And we're going to say, instead of rental car, we'll say rental vehicle. And now we'll create a public class rental car that inherits from rental vehicle. Cool. And now I can look at this and go, okay, we're pretty good. We can probably create a truck as well. Let's move this over to its own class first. Okay, so now we have rental vehicle and rental car. We're good. We've got everything we need because that's, all that stuff is still applied. By the way, we just copied it again. We're going to probably copy this over a number of times. I'm just going to leave it. That's fine. So now we have rental vehicle. We can come back over here to rental car. We can, in here, outside of rental car, we can say public class rental truck, which inherits from rental vehicle. Cool. And let's do control dot here to move to its own file. So now we have rental car, we have rental truck, we have rental vehicles. Now, we got a problem though, because when you look at car type, that applies to cars. And if we look at that enum, none of these apply to a truck. So we could say, well, let's put short bed and long bed truck in there. But now you've got an enum. First of all, it says car type. We got to change that. But then do you even want the option of selecting a hatchback truck? Because that makes no sense. So no, we can't do that. So now what we need to do is we need to have a public enum truck type. That shift enter is not working for enums, evidently. So the shift enter at the end of any type that needs a curly brace should add the curly braces and put your cursor inside of it. It works for classes, namespaces, methods, but evidently not for enums. I'm going to actually turn that in as a possible bug. But these two would come down here. Okay, so now we have car type and we have truck type. But in here we have this car type with our style. Well, let's cut this out of here and put it into rental car. And we're going to put in rental truck, something similar, but it's going to say truck type. And this is an important thing to note. Just because we have the same name or same property doesn't mean we necessarily have the same thing stored in it. So right now it's a little more obvious. We have style for both car and truck, but we have the type is car type versus truck type. So it's a little more obvious. But that property, even though it shares the name style, they're different. They're not the same. It gets a little more subtle when they have the same type and the same name. For instance, and I'm just going to use this as an example, but what if we put in the car type, we put a prop for weight? Okay, now what do you think that the weight would be in? For a car, if you're in the US, probably in pounds. If you're in the rest of the world, probably in kilograms. Okay, but what if we had another class, let's just say public class Matchbox car. If you're not familiar, a Matchbox car is a little tiny car. Okay, well that might have a weight property as well. You may say, cool, those share the same property, so we could inherit both of those from the base car object. But is that weight really the same as that weight? I mean, yes, they're both weights, but this one up here is going to be storing in pounds or kilograms. Down here, we're going to be storing in grams or ounces. So it's not the same. Even though it's storing a number that represents weight, they're different. So just because the property names are the same and even the types potentially doesn't mean that they are the same. All right, so getting back to our example, we now have a more robust system. We've used inheritance to help us out because we have this base class called rental vehicle. And rental vehicle has our properties and our methods that are shared by both rental truck and rental car. And yet rental car and truck, let's get rid of that, they both have their own properties and or methods as well. So we're good there. We think life is good. Our fleet is growing. We now have 7 or 8 vehicles, including a couple of trucks. Cool. And then our boss comes to us and says, you know what? We're in Miami, Florida. And one of the things that Miami, Florida is known for is water. So we're going to add to our rental fleet a couple of boats. And you're like, uh-oh. And think, well, no. We've got this rental vehicle and let's see, it's a speedboat. So rental information still applies. Number of passengers, it's a stretch, but it could still apply. And start and stop engine, well, we might have to override these and change this a little bit, but probably it'll work just fine. So cool, let's go ahead and do it. So we'll create, this in one of these methods right here, or classes. We say public class rental boat. And we'll inherit from rental vehicle. And then we'll say, you know what? We don't need to add anything. We'll leave a style off, including we don't have to have a style. It's just a boat, right? So, and I'm assuming that rental boat, let's move it to its own type, is a powered boat. Like it has an engine in it. Whether it's an outboard motor or it's a internal motor, whatever it is, that boat's gonna run. And so we're good. You've got a start and stop engine. Maybe it turns by a key, so cool. And our boss says, actually, we've got 2 different types of boats. Like, okay, one of the boats is a sailboat. And now you're in a corner. And now you're really in trouble. Because let's look at this. And we're going to come up here and we'll create this class in here and we'll move it out in a minute. Public class rental sailboat. And we're going to inherit from rental vehicle. All right? Because it has a rental ID. It has a current renter option. It has a price per day. We could even say it has a number of passengers. But here's where the sticky bit comes in. Start engine. It's a sailboat. It doesn't have an engine. Stop engine. Same thing. If you can't start an engine, can't stop it. So what do we do here? Well, we can't inherit from rental vehicle. Otherwise, what we have to do is override these methods and say, well, let's actually just do it. So make these virtual. So we can override them. And we'll come up here and we'll say public override and start engine. And we're going to say here, throw new exception. I do not have an engine to start. Okay. And we'll have to do the same thing with this. Public override stop engine. And again, throw new exception. I do not have an engine to stop. Okay, so we're kind of in a corner. Now we've got these classes that have methods that not only don't do anything, they actively should not be called. Because if you're calling start engine on a sailboat, you've got a problem. Because if there is no engine, what are you doing? And if you expect the vehicle to start doing something because you push start engine and nothing happens, you've got a problem. So you have to have these throw new exceptions to say, hey, you can't do that because I don't have one. But that means that the inheritance now is all wonky. We have this weird code where we've got code that actively fails, that actively doesn't work the way we want it to, and we have to have this institutional knowledge to say, I know that rental sailboat has the start engine method, don't call it. Well, that's messy, especially when you have 30 of those methods scattered throughout your code. Now you go, okay, oh yeah, that's right, this is a sailboat, we can't call that method. And if you do, you've got problems either because you intentionally throw an exception, and you should, or you don't intentionally throw an exception, and now there's an expectation that something happened when it didn't. When it comes to start engine, it'd probably be pretty obvious that nothing happens. But if maybe this was record latest transaction, and it's supposed to record it to a database, but this particular class does not have access to a database. Well, if you expect it to record to a database and you say, go ahead and record, and you never listen for a reply because it's a one-way, just do it, well, then you could have the expectation that recording was happening when it wasn't. And that could be a huge deal. So you really don't want to have these without exceptions, but now you've got these weird exceptions you're throwing in your application for people calling methods that exist, and they shouldn't. So this is where I say that you really work yourself into a corner when it comes to inheritance, because it made sense. Oh, it doesn't make sense anymore. And that's the problem, because you got this weird, is a rental car a rental vehicle? Well, yes, but is that really the inheritance structure we need? Is that really what the value is we're giving it? And we were trying to do two things here. We're trying to do a rental and we were trying to do a vehicle. And we thought those two went together pretty well. And even if we separated those two and said, okay, we're going to have a vehicle be the base class and then a rental be a child class of that, and then the car be a child class of the rental, so it has both vehicle and rental, it wouldn't matter. So we still have this mess because now we've got a rental that's not a vehicle that's not a rental, or a rental that's not a vehicle, but that doesn't work. So it makes this really big spaghetti mess of our code. And you could say, well, drop off vehicle and just have this information and not do the vehicle portion of it. And that's possible. But what's the value in that? We have 4 properties. How is that really helping us in any way? You may say, well, we're not repeating ourselves. Yeah, you're not, because you're just inheriting from rental at that point and getting these 4 properties, but you're also locking yourselves into the rental base class for just 4 properties that are auto properties. There's got to be a better way, and there is. So let's talk about a different way. So I'm going to create a better way. So let's right-click on the solution, and we're going to say add new project, console app, and we'll call this better OO demo. So again, this is just to keep them separate, so you have 2 different ones to look at. We're not actually having runnable code at the end of this. I just want to point out the differences. So we've got this idea of a rental, and we have vehicles. So let's create an interface. Let's just do it. Actually, let's do it right here. We'll again bump it out. Public interface. Let's call this iRental. We're going to say that this is going to be the interface for renting vehicles. And let's go back to our rental vehicle for a minute and just grab these 3 right here. And go back here, and we'll paste them in, take the publics off because it's an interface. There we go. We have rental ID, current renter, and price per day. So it's a rental now. All right. So that's going to be the interface we apply to anything that is a rental. Okay. So let's move that off into its own file. Now let's create our vehicles. So I'm going to say public class vehicle. And we're going to do some inheritance. So number of passengers seems to work for all of our vehicles. So let's grab that. And you say, well, that's not really that great of an inheritance. You're right. So let's bring over those 2 methods. And you may say, well, Tim, then we can't inherit boat in here. And no, we can't. Boat can't be a vehicle. Now, if you want to say that vehicle is too generic because a boat seems to be a vehicle, then we will say a land vehicle. Okay? Now, yes, naming could be better. We could maybe make it auto, because a truck can be an automobile. We usually think of automobiles as cars. So, yeah, naming's hard here. But let's just call it land vehicle. That's cool. All right, so now we can move that into its own class or own file. And now we can create that. Let's copy over our enums. So copy, and we will paste. Just check to make sure that it has, wrong namespace. So the namespace is better OO demo. So let's make sure we change that. Otherwise we'd have a problem with namespaces. So we've got the same types, so we can just do our car and our truck. So let's grab that one thing there. And we're going to say public class rental, or just car. And we're going to inherit from our land vehicle. And we're going to have the interface of iRental. All right, and now we'll paste in our 1 extra property, and we're going to go ahead and implement this interface. Control dot, implement that interface. Done. All right, and let's move that over to its own car.cs. We're going to grab the truck here. We'll grab that one property. We'll come back over here, and we'll examine these in just a minute. But public class truck, again, it is a land vehicle, and I rental. We'll paste in that one property. We will control dot to implement the interface, and we're done. Okay, so now we have the car and the truck. And so with that, we've got the inheritance structure, which allows us to have the start and the stop. It allows us to have number of passengers. We have some shared logic, not just shared properties, not just shared signatures. We have the idea that they're both a land vehicle. A car is a land vehicle. A truck is a land vehicle. We could add more types of land vehicles. SUV. We could even add things like moving truck. That would also still fall under land vehicle. But we also have this idea that we have the interface for iRental. So we are essentially making a duplicate of these properties. And that's where people get a little stuck. And they say, oh, that's a problem because that's repeating ourselves. And the first most basic and most powerful of our design principles is dry. Don't repeat yourself. And yes, that is an admirable goal, not to repeat yourself, but this is not repetition. And the reason it's not repetition is because what code did I write for these three properties? What logic did I write for these three properties? Well, I didn't. There is zero logic here. It's just, I'm illogical. No, there's zero written logic by me that affects these off the standard. So price per day, this one right here is the exact same, and there's no modifications to the getter or the setter even. So this is very, very simple code. This right here, you can repeat all day long. The reason why dry exists, always remember to go back to the reason why we say don't repeat yourself. It isn't about writing less code. The point of don't repeat yourself is if you write a method, let's look at our rental vehicle, this method right here. So what if I didn't write that line right there? So I just have turn key to on. Well, that doesn't actually start most cars. You actually have to turn to the ignition setting first and then back it off to the on setting. Well, if I forgot that and I have this written in the car class and the truck class, and I go, oh, that's right, I need to turn the car ignition to on. I have to come to the car class and add that logic. I have to come to the truck class and add that same logic. That's the repetition we're being careful of, because if I forget it in one class, then what happens is I've got a bug where it works most of the time, but not all the time. And that's what dry protects us from. So this is not a case where we have to be protected. There we go. This is not a case where we have to be protected by that repetition. iRental makes sure that we have the same properties. So we're protected against, typing it differently, calling it rental identifier instead of rental ID, those kind of things. We're protected from that. And the only thing we have to look out for is if we had some kind of logic in our getters or setters. So that's one reason why this is not a violation of dry. But there's another thing to think about, and that is this is inevitable duplication. Because of the fact that we cannot have both inherit from multiple things. There's not multiple inheritance. So we can't inherit from a rental and from land vehicle. And the two things aren't related. A rental information has nothing to do with vehicles until you attach it to a vehicle. So it's not like it is the parent, like a vehicle is, like a land vehicle is a parent to a car and a truck. There is not an inheritance structure that also brings in rental in some way that makes sense. So therefore, you are faced with the idea of, yes, we have to have some duplication of the implementation of our logic. And that can be okay. In this case, it definitely is a requirement. Now let's close this all out. Let's save that change. Let's close all these out so I don't get confused with which one's which. And we're gonna go back to our back to program.cs is fine for our better OO example. And we have to now deal with the idea of let's just deal with rental sailboat. So we have this rental vehicle and we have this rental sailboat. Let's move this off into its own class. There we go, own class. Let's open it up. So we have to deal with this rental sailboat. Okay, so we say public class sailboat. And it is a iRental. And let's go ahead and implement that. Whoops. Implement interface. We're done. Okay, there was no extra properties and methods in here that I added. Of course there would be, but we didn't actually add anything here, so we don't have to add anything over here. We're done. We just didn't inherit from land vehicle, which is okay. That's fine. We can create its own type. Now, we actually going to use this. You're going to say, yes, but Tim, how do you deal with this? Well, we're going to say, let's get rid of console write line. We're going to have probably a list, control dot to add the using statement using system.collections.generic, a list of iRentals. This is what the rental agency will have. And it's going to have, just call it rentals. And then in here, we're going to have, let's just add a new truck. Cool. And let's add something in here just so we can see this as a truck. We're going to add the current renter. So I'm going to change the current renter every time to be the name of whatever the item is. So current renter equals truck renter. Okay. And we're going to say rentals.add new sailboat. And we're going to say the current renter is sailboat renter. And just for sake of completion, rentals.add new car. And we're going to say the current renter is car renter. Okay, so now we have our list. We can loop over these and say, okay, how much is it per day? Let's just show it. For each, there we go. For each, let's just say R in rentals. We can say console write line R dot. We have current renter. We have price per day. We have rental ID. Now that's it. That's all we have access to. And you say, okay, but I need to know things like, well, how many passengers does it have? Or actually, I think that's in the list. Nope, it's not, because passengers is not part of our, we don't have a base class for that. So we don't have in the base class, we have just the iRental. So we can't access even passengers. Well, not everything has passengers. So how do we know to ask if it has passengers? Well, we can say if R is truck T, and we can say T dot, and we have the number of passengers. We have the price per day. We still have the rental ID. We have a start engine, stop engine, and style, and that's the truck style. Okay, so we can say style, and we say equals truck type dot long bed or short bed. That's our options. So we have this ability to kind of convert or cast this to the truck type T. Now, here's an important note that you might get a little stuck on. This is not making a copy, okay? This is identifying if this variable is actually a truck. And if it is, we're gonna put that instance into T. It's not making a copy of the instance, it's the same instance. It's just pointing to the truck and saying it's actually truck type so you can access the truck properties and methods. So this is not a really inefficient way of doing things. It's actually pretty efficient. So we can actually investigate this and say, oh, is it a truck? And we can say, if R is a sailboat, then we could have, the sailboat methods, which there's nothing additional there. So we can check for all these things and do additional things based upon not just that iRental, but also the truck properties for just trucks, and the car properties for just cars, and the sailboat properties and methods for just sailboats. So we have the ability to still access those things even though we're referencing based upon iRental. But the rental agency can just throw whatever it wants into that iRental list. Because now, if down the road we say, okay, now it's time to rent other things, we're going to rent tanks, which that's kind of crazy. Well, tanks they still are land vehicles, we could possibly say, but you know what, we're going to say military vehicle instead. And we're going to have, instead of inherit from land vehicle, we'll inherit from military vehicle. We're going to have things like number of operators, not passengers. There's not really passengers in a tank. There's operators and there's nothing else. It would have other values there. And then we could add things as well that might be unmanned, or it might be whatever the case may be. We can rent whatever. This could be, Bob's Rental Shack. We rent anything. TVs, no problem, because we have the properties. If you look at iRental, there is the rental ID, who's renting it, and the price per day, which that applies to anything. So you want TVs? No problem. We can add TVs to that list, and we can even still add it to this list of things we rent. And so if you rent land, if you rent apartment buildings, if you rent whatever it is, we can rent it in our list because they're only iRentals. And we're not stuck in that inheritance structure trying to fit in, well, how do we inherit with vehicles and all the rest? That instead of making a mess of that like we did in the first demo, we can say iRental is probably an interface because the only thing that really connects them all is the fact that they're rentals. And that's not a relationship. But things inside the things we rent may have a relationship, like land vehicles. So you can have one category as land vehicles and have common properties and methods that apply to all land vehicles. And then underneath that, we can have the land vehicles that we rent. So if you look at the animal example again, so we have, a cat is an animal. Well, if we have a zoo, well, there's a whole bunch of things about being an animal in the zoo. We could say, well, they all have their own, name we gave them. They all have their location where they live. They all have their own trainers. But that's really going to probably be an interface, and then we'll still have our inheritance structure of animal with all the different ways of inheriting underneath that for child classes and grandchild classes. So this is what I mean. Let's go back to, it's probably all over, right? Yes, it is. This thing's all over, so you can find it pretty much wherever. But it's not about just code sharing, okay? Because if you just try and do code sharing, you end up with this messy thing that we're working with here. You have to have the bare minimum. You have to have that is a relationship. And don't stretch that. When you stretch it, that's when you get into trouble. We stretched it when we said rental vehicle was the parent to child relationship with our elements like car and truck and boat. So that was a stretch. Well, when we stretched it, we ended up breaking it with rental sailboat. Okay. And if we had a rental TV, that would, shatter it, because number of passengers in a TV, none. So don't stretch the is a relationship. And we need to share common logic, okay? And not just properties or method signatures. So if we have code sharing, which I hate calling it that. But if we're sharing code, we shouldn't just be sharing this and overriding the actual results every single time. Otherwise, if you have to override the method every single time, what's the point of having the method in the first place? Because really what it sounds like is you've got an interface. And if you have an interface, you can have multiple of those. So if you have multiple interfaces, then no problem. You can, apply them, and you can even do things like what we did over here. We say, is a truck. We can say is a iRental, is a iVehicle, is a I whatever, and you can look for different interfaces and capture or use those properties and methods inside that particular interface. So you can have multiple of those, and they don't have to have the same structure of inheritance and single inheritance that actual inheritance does. So make sure that you're not just sharing method signatures or properties. Inheritance can put you in a corner like we saw, so be careful of that. Again, it comes back to stretching this is a relationship. And what's the point? Okay, ask yourself, what's the point? What was the point of us trying to work that into an inheritance structure somewhere? Was that really valuable in some way? What was the benefit of doing that? And if you want to have a code sharing mechanism where we say, okay, this is the common checkout procedure for all rentals, which there probably isn't one, but if there was one, we could actually create a method in here that, of course, is just a signature, but then create a separate method somewhere else in a different class that is checkout rental, that takes in iRental object and it does work on it and it checks it out. Well, that's code sharing. That's code reuse. And you wouldn't have to put that in inheritance structure. It can be separate from the process entirely. So make sure that you ask the question, what's the point, and make sure you have a great answer. Now, I do have more videos on this channel that cover more object-oriented programming, and we've talked about things like dry. So I do want to point out, if you go to my channel, go to the main page here, there is 2 different search bars. Okay, there's a search bar up top, that's searching all of YouTube. But then if you, on my channel, there's this search bar down here. If you search here, it will search my videos. So if you search for dry, well, there's a video on dry. There's also a video on design patterns that might be helpful. But then if you notice down here, there's dependency inversion principle. This is another OOP principle. And that's the whole solid. Well, actually, if you search for solid, you're going to find SRP, open close, list cost substitution, ISP, and the dependency inversion principle. So all 5 of the solid methods. There's also dry. There's a playlist with design patterns and principles. There's also things like interfaces. Abstract classes is down here. So I've covered a lot of object-oriented programming stuff in other videos as well. If you're confused or if you want to see more information about one particular thing, check that out. If you want to learn more about interfaces, there you go, interfaces. So it'll talk you through more in depth on how to use them, or abstract classes or whatever. So I encourage you to use all those resources to really dive into this subject. Learning object-oriented programming is important because C# is built upon object-oriented programming. Knowing how it works, knowing why it works is kind of critical to actually using C# to its full extent. If you have questions, if you have thoughts on this topic, leave them down in the comments below. Let me know what you thought, and let me know if there's other object-oriented programming topics that maybe are confusing to you or you're not quite sure on. But just make sure you use that channel search first and see if I haven't already covered it. But I've covered a lot of them. All right, thanks for watching, and as always, I am Tim Corey.